Why do Northern U.S. homes have basements while Southern homes usually don't? Put two ordinary American houses side by side. One is outside Minneapolis. The other is outside Houston. From the street, they might not look dramatically different: siding, garage, driveway, maybe a small porch. But one of them may be hiding an entire extra level underground, while the other is sitting almost directly on a concrete slab. That difference can change where the furnace goes, where holiday decorations are stored, where kids play, where a storm shelter might be, how plumbing is repaired, and even how a house feels in summer. So why did one part of the country get a hidden floor while another mostly did not? The answer starts with something that sounds almost too boring to shape American architecture: frozen dirt. And once you understand what frozen soil can do to a house, basements stop looking like a lifestyle choice. They start looking like the side effect of a construction problem. A house has to transfer its weight into the ground without moving too much. That sounds obvious, but the ground is not a perfectly still platform. It gets wet. It dries. Some soils shrink and swell. Groundwater rises and falls. And in cold climates, the upper layer of soil can freeze. When moisture in frost-susceptible soil freezes, the problem is not simply that water turns into ice and gets a little bigger. Under the right conditions, water can move toward the freezing zone and build layers of ice in the soil. Engineers call them ice lenses. As those lenses grow, they can push the ground upward. That movement is called frost heave. A sidewalk can crack. A deck post can lift. A shallow footing can move unevenly. And if different parts of a house rise and settle by different amounts, doors can stop fitting, walls can crack, and the structure can be stressed in ways nobody wants. The traditional defense is simple: put the important supporting parts of the foundation below the depth where the soil is expected to freeze. Modern residential codes also allow other engineered solutions, including frost-protected shallow foundations that use insulation to keep vulnerable soil from freezing. But for a very long time, the straightforward approach in cold regions was to dig down. And that creates the first big clue. If a builder already has to excavate several feet, pour footings down there, and build substantial foundation walls back up toward ground level, the project has already paid for a lot of digging and a lot of wall. At that point, digging somewhat deeper and leaving usable space inside those walls can make economic sense. Not free space. Basements are never free. They need excavation, structure, drainage, waterproofing or dampproofing, a floor, stairs, and often insulation. A finished basement needs much more. But compare that with a warm place where there is little or no frost-driven reason to put the foundation deep into the ground. There, a builder may be able to prepare the site, run utilities, form the perimeter, and pour a slab close to grade. Now a basement is no longer a convenient extension of work that already had to happen. It is an optional underground construction project. That is a very different calculation. The regional pattern is strong enough to show up clearly in housing statistics. Census data tracks slab, crawlspace, and basement foundations as distinct categories. In a recent census-based analysis of homes started in 2024, roughly 3/4 used slab foundations nationwide, while full or partial basements were a much smaller share. But the national average hides a dramatic map. In New England and the northern central states, basements remained common. In the West-South Central Division, which includes Texas, Oklahoma, Arkansas, and Louisiana, almost all new single-family starts in that 2024 analysis were on slabs. The South Atlantic was also overwhelmingly slab. So this is not just a stereotype created by real estate listings. It is a measurable regional difference in how American houses meet the ground. And the frost line explains a surprisingly large part of it. Imagine you are building in a cold northern city. The exact required depth varies by location, soil code, and local conditions, but the principle is the same. An unprotected shallow foundation cannot simply sit in soil that predictably freezes and heaves. If the safe structural work is already happening deep below grade, a basement can become the useful byproduct. Now move the same house south. In a warm climate, the frost problem shrinks or disappears. A deep excavation may provide more square footage, but the foundation no longer needs that depth for the same reason. A slab can be faster, simpler, and cheaper to build. And on a large subdivision, saving time and material on one house matters. Saving it across 200 houses matters a lot. This helps explain a fact that can seem backwards at first. People sometimes assume basements are common in the north because homeowners there desperately need indoor recreation space during long winters. That may make a basement more desirable once it exists. But it is not the deepest cause. The construction logic came first. The lifestyle followed. Once northern houses regularly had cellars and basements, those spaces collected jobs. Older American houses provide a kind of archaeological record of this. Historic homes documented by the National Park Service show basements containing fruit cellar rooms, coal rooms, furnaces, and laundry areas. That makes perfect sense. A below-grade room stays more thermally stable than an exposed shed. It can hold food and supplies. It can keep dirty, noisy, or bulky equipment away from the main rooms. And when central heating spread, the basement was a natural place for furnaces and boilers. Then came water heaters, electrical panels, plumbing branches, laundry machines, workshops, freezers, storage shelves, and eventually finished recreation rooms. The basement became the mechanical backstage of the American house. That legacy still shapes houses today. In many northern homes, contractors expect to find important equipment downstairs. Buyers expect storage. Real estate listings distinguish between finished and unfinished basement space. Entire habits develop around a room that began in part because the foundation had to go deep anyway. In much of the South, a different chain reaction happened. When slab-on-grade construction made sense, the house had to put those same functions somewhere else. The water heater might go in a garage, closet, attic, or utility room. Vac equipment may be in an attic, mechanical closet, garage, or other dedicated space. Storage moves to garages, closets, sheds, and attics. Laundry is planned into the main floor. The absence of a basement changes the floor plan above it. And this is why foundation choices are more important than they look. They do not just hold up a building. They quietly decide where the building's organs will live. Climate is only the beginning, though. Water can reverse the logic. A basement is a large below-grade box, and below-grade construction has to manage water from several directions. Rain can saturate soil around the foundation. Groundwater can rise. Water can move through cracks or joints. Moisture can migrate through concrete. Poor drainage can turn a useful lower level into the most troublesome room in the house. Modern basement construction deals with this using site grading, perimeter drainage, water-resistant layers, sump systems where needed, and careful detailing. Done correctly, basements can stay dry and comfortable. But every one of those measures is another reason a basement is not simply cheap extra space. In places with high water tables, the challenge becomes even more obvious. Some soils in Florida, for example, are officially described as poorly suited to basements because of seasonal high water tables. And in flood-prone areas, federal floodplain rules can make below-grade spaces a serious liability. FEMA's rules generally do not allow residential basements below the base flood elevation in regulated flood hazard areas except under specific community exceptions. So in parts of the coastal South, builders may face exactly the opposite of the northern incentive. Up north, soil freezing can reward going deeper. In a flood-prone coastal area, water risk can reward staying higher. That is a powerful contrast. It also helps explain why the South is not one simple construction zone. A house in the mountains of North Carolina is not dealing with the same site as a house near the Gulf Coast. A home on a steep Tennessee lot may have a walk-out basement because the slope practically creates one side of the lower level for you. A house on flat, wet coastal ground faces a different set of costs and risks. Topography can be just as persuasive as temperature. On a sloped lot, a builder may cut into the hillside so that one side of a lower level is underground while the other side opens directly outside. That is the classic walk-out basement. It can bring in daylight, provide an exterior door, and turn a foundation solution into valuable living space. On a flat lot, creating the same lower level means excavating the whole footprint and then managing soil and water around every side. Same country. Same basic house. Very different math. Soil adds another layer. The United States contains an enormous range of soil conditions. Some ground drains readily. Some holds water. Some contains expansive clay that changes volume as moisture changes. Some sites hit shallow rock. Some are easy to excavate. Others make every extra foot expensive. This is why a map of basements never perfectly matches a map of winter temperatures. Builders are solving a local puzzle: frost, water, soil, slope, code, labor, material prices, construction speed, and what buyers in that market expect. The solution that wins repeatedly becomes tradition. And tradition eventually starts to look like a law of nature. Texas offers a good example of how people can oversimplify this story. Someone may say Texas houses do not have basements because the water table is too high. That can be true in some places, but Texas is enormous. Groundwater conditions vary. Soil conditions vary. Elevation varies. Another person may say it is because Texas has clay. Expansive clay is a real foundation concern in many places, and the U.S. Department of Agriculture warns that expansive soils can require stronger foundation systems. But clay alone does not explain an entire state's architecture. The bigger pattern is economic and climatic. In a region where deep frost protection is usually not forcing builders to excavate far below grade, a slab often starts with a major advantage. Local engineering then adapts that slab or other foundation system to the site. That distinction matters because it keeps us from turning a regional trend into a fake universal rule. Basements are possible in the South. Slabs are possible in the North. The real question is what each location makes easiest, safest, and most economical. In fact, modern engineering has weakened the old connection between cold weather and deep foundations. A frost-protected shallow foundation can use insulation around the building perimeter to control how deeply frost reaches near the foundation. The International Residential Code recognizes this approach. In other words, a cold climate house does not always have to get its frost protection by digging a traditional deep foundation. That is a fascinating change because it separates two ideas that used to travel together. One idea is structural: protect the house from frost. The other is architectural: create a basement. For decades, the first often made the second attractive. New technology can solve the first without automatically giving you the second. And the market appears to be moving in that direction. The share of new American single-family homes built on slabs has risen dramatically since 2000, while the share with basements has fallen. Even some northern regions have been using more slabs than they did a generation ago. That does not mean basements are disappearing tomorrow. Existing housing stock changes slowly and northern buyers still value them. But it shows that the hidden floor under an American house is not inevitable. It survives where its benefits still justify its cost. Those benefits can be substantial. A finished basement can add a large amount of usable floor area without making the house taller or expanding its footprint. It can become a family room, office, gym, guest area, workshop, or storage zone. Because part of the space is surrounded by soil, temperatures may change more slowly than in rooms fully exposed to outdoor air. But underground space also comes with rules that above-ground rooms do not have to think about in the same way. Moisture is one. Safe emergency escape is another if the basement contains sleeping rooms. Insulation details matter. Drainage matters. Combustion equipment needs proper installation. Radon can be a concern in many parts of the country regardless of whether a house has a basement because the gas comes from soil and can enter through foundation openings. A basement gives you space, but it also gives you another building envelope to manage. That is one reason an unfinished basement can look deceptively simple. Bare concrete walls, exposed joists, a floor drain, maybe a furnace in the corner. It feels like empty leftover volume. It is not. Those walls are holding back soil. The floor and walls are interacting with ground moisture. The foundation is carrying the house. Pipes and wires are concentrated there. The space is part structure, part utility corridor, part environmental control system, and sometimes part shelter. This brings us to one of the most persistent basement myths. If you ask why basements are common in parts of the Midwest, someone will eventually say, tornadoes. There is a grain of truth in that answer. FEMA guidance says below-ground space is generally a safer refuge location during extreme wind events, and a properly designed safe room can provide a very high level of protection. But tornadoes do not explain the national basement map. If they did, some warm parts of the central and southern United States would be packed with basements. They are not. The better explanation is that cold northern areas already had a construction reason to go below grade. Once the basement existed, its potential value during severe weather was another benefit. That is different from saying it was the original reason to build one. This is a recurring pattern in technology. A feature created for one purpose survives because it becomes useful for 5 others. The basement starts as foundation depth and storage. Then it becomes the furnace room. Then the laundry. Then the workshop. Then the rec room. Then the home office. Then the place where everyone heads during a tornado warning. By the time a family moves into the house, the original geotechnical reason is invisible. All they see is stairs going down. The crawlspace tells the same story in miniature. A crawlspace lifts the first floor above the ground and creates access to plumbing and other systems without excavating a full-height basement. Federal Building Science Guidance notes that crawlspaces have historically been especially common in marine, mixed humid, and hot humid climates where frost depths are often more moderate. It is a compromise. More separation from the soil than a simple slab. More access to utilities. Less digging and less below-grade wall than a full basement. But crawlspaces bring their own moisture and air sealing problems. Older vented crawlspaces in humid climates can allow warm, moisture-heavy outdoor air to reach cooler surfaces under the house, where condensation becomes a concern. Modern guidance increasingly favors carefully sealed, insulated, and moisture-managed crawlspaces in many situations. Again, the empty space under a house turns out to be part of the building system. And once you start noticing foundation types, American neighborhoods begin to look different. In a northern subdivision, small basement windows near the ground may reveal an entire lower level. Window wells hint at rooms buried behind the lawn. A raised first floor may mean the foundation wall extends several feet above grade. In a Sun Belt subdivision, you may see the opposite: low entries, garages nearly level with the driveway, mechanical equipment moved into attics or closets, and hoses spread horizontally because there is no hidden floor underneath. Neither design is automatically better. A slab can reduce excavation, simplify construction, and eliminate the problem of a wet basement. It can also make access to some pipes more difficult if they are embedded below the slab. A basement can offer flexible space and convenient access to many utilities, but it demands serious water management and costs more to build. A crawlspace can provide access without the expense of a full basement, but it has to be treated as a moisture control problem, not forgotten as a dark gap under the floor. Every foundation is a trade. What is interesting is how those trades become culture. Think about the classic American basement images: the old furnace, the workbench, canned food on shelves, a washer and dryer, a teenager's bedroom, a pool table, boxes nobody has opened in 15 years. Those are not random clits. They are the cultural afterlife of a structural decision. Now think about the southern garage packed with tools, storage bins, a second refrigerator, lawn equipment, and household overflow. Part of that difference comes from the missing basement. The storage did not disappear. It migrated. The mechanical systems migrated too. Architecture changes behavior, and behavior makes the architecture feel normal. A Midwesterner can walk into a Florida house and feel that something is missing beneath their feet. A Floridian can walk into a Michigan basement and wonder why anyone volunteered to build an underground room that needs drains, waterproofing, dehumidification, and a sump pump. Both reactions make sense. Each person is looking at the other region's costs without automatically feeling its benefits. There is another reason this story matters now. America is still building a huge share of its new housing in warmer regions. At the same time, builders everywhere face pressure to control costs, shorten construction schedules, and use systems their crews already know well. That pushes the industry toward repeatable local solutions. A foundation type is not chosen fresh from a blank sheet of paper for every house. Builders have suppliers, subcontractors, engineering details, equipment, inspection routines, and customer expectations built around what is common in the area. If nearly every house in a market is slab-on-grade, the entire construction ecosystem becomes good at slabs. If buyers expect basements, builders design around basements. Regional habits reinforce themselves. That is why changing the code alone does not instantly change the neighborhood. And it is why the basement question is really bigger than basements. It is an example of path dependence, the idea that an old practical choice can shape future choices long after the original problem has become easier to solve in other ways. Cold soil helped make deep foundations normal in the north. Deep foundations helped make basements economical. Basements created space for heating equipment and storage. Those uses made buyers value basements. Buyer expectations helped keep builders building them. One physical constraint created an architectural habit, and the habit became part of regional culture. Meanwhile, warm climate construction followed another path. Shallow foundations were practical. Slabs were fast and economical. Utilities moved elsewhere. Home plans evolved without underground space. Builders specialized in those plans. Buyers stopped expecting stairs to a lower level. Two regions solving the same basic problem, how to hold up a house, ended up with very different ideas of what a normal house should contain. And the trend is still evolving. Better insulation makes shallow, cold climate foundations more practical. Better waterproofing makes basements more reliable when they are worth building. Changing construction costs can shift the balance. Climate risks can alter flood and moisture calculations. Housing demand can push builders toward simpler foundations or toward finished lower levels that squeeze more usable space from an expensive lot. There is no final answer carved into concrete. There is only a set of forces pushing the decision one way or another. So the next time you see a basement door in Ohio or a slab-on-grade house in Texas, the difference is not just regional taste. You are looking at climate translated into construction. You are looking at groundwater, soil, labor, building codes, old heating systems, local real estate expectations, and decades of habit all compressed into the few feet between the living room floor and the earth. And the strangest part is that one of the biggest features inside an American house may have been created by something outside the house entirely. Not a designer, not a homeowner, not even a builder, just the depth at which winter stops freezing the ground.